Okay. Hi everyone, my name is Bogdan and I'll be talking today about examining access control vulnerabilities in GraphQL and also in REST APIs. So if you're interested in API security, you're in the right place. And this will be a case study on the FeeId dating app. So we will go through a couple of vulnerabilities that I found in the FeeId dating app, 8 access control vulnerabilities. We'll take them one by one, all related to access controls, and we can see how bad things can go. So who am I? Bogdan Tiron, 10 years of experience in security, senior Pentester at FORTBRIDGE, certifications in pentesting, DevSecOps, and cloud security, especially GCP, and I've been working in the banking and gambling industry. Quick question, I'm curious about you. How many developers are in the room? Web developers? Okay, quite a lot. Security people? Okay, a lot less. Okay, DevSecOps people? Okay, less. And managers? Okay, okay, cool. Okay, I'll try to cover a little bit from each area. So what is this talk about? It's about the importance of access controls in the APIs. Let's see how important the access controls are in the APIs in web applications. According to OWASP Top 10, for API security risks in 2023, this issue access controls are on first place and are known as BOLA category, Broken Object Level Authorization category, and are on the first place. And then according to OWASP Top 10 for web applications, access controls are also on the first place and are known as broken access controls category. So according to OWASP Top 10, we can see that the access controls are the most important for APIs and web applications. Okay, what is FeeId? FeeId is a dating app and it launched in 2014 under the name of Trender. As the name implies, it was focused solely on threesomes. In 2016, because of a naming conflict, Tinder Trender, they renamed to FeeId and became more open to the idea of dating in general. So FeeId is a dating app, just like all the other dating apps, Tinder, Bumble, etc., where you can filter by distance, age, gender, there are more than 10 genders, couples, or by location. For premium users, you can search by the type of kink you're interested in, or the type of relationship you're interested in. And on Android, it has more than 1 million downloads. So it's a dating app. Let's see the menus. So we have 4 menus. The first one where you discover profiles where you can see the photos, name, how far the person is, a short bio, and what the person is interested in. Then you have the Who Liked You menu, the second menu, where as a basic user you cannot see much, only the name, and you cannot interact with the buttons. You have to pay for the premium subscription. Then you have the third menu, Messages, where you message the people you matched with. And then the last menu, My Profile, where you upload your profile photo and other photos, and you edit your bio, and you buy premium subscription. So this is how the app looks like. Now, as I mentioned, I found 8 vulnerabilities in this dating app, and we will be taking them one by one and see how access controls impact the application. 7 of them, as you can see, are related to BOLA, so access controls, and one of them is from BOPLA category, which is very similar. However, what's the difference between BOPLA and BOLA, in case anyone knows? All of them are similar. In the BOLA, you should not have access to the data of a different user ID. In the BOPLA, you should have access to someone else's user ID, except some very specific properties from that user ID, where you should not have access to those sensitive properties under that user ID. So similar, but some very small nuances. So let's take them one by one and learn about these 8 vulnerabilities. The first one, disclosure of profile information to non-premium users. So what happens here? So as a basic user, you will no longer need to pay for the premium subscription to get the premium benefit. As a basic user, if you go to the second menu, the likes menu, you can see who liked you, but everything else is blurred and inaccessible. As a premium user, you will get all the information to you. However, if we use a proxy tool such as Burp, we intercept the request and the response, and we read it, we will have access to all the information available. So let's reproduce the issue and see how we can get the benefits of a premium user for free. So we go to the likes menu, we see who liked us in the app. We intercept the request, and we will see in the request there is a request to the GraphQL endpoint and an operation name called likes query. And in the response, we see who liked us. For example, imaginary name Sam, interaction status, Sam liked us, we didn't like Sam yet. Where is geolocated Sam? Sexuality, photos. And if we copy the URL in this photo array, from this photo array, and we paste it in the browser, this is what we will get. So we will get Sam's photo, and if we match with what we see in the mobile app, we will see it corresponds to the first photo of the user Sam, just that in the mobile app is blurred. So we managed, as a basic user, to get access to premium benefits for free. And another important property that I've mentioned that we should not have access to is this stream user ID, which is unique to every user, and we will use this property to exploit the next issue. So let's see the next issue. Read other people's messages. So we can read other people's messages in the chat, and in order to do that, we will need that stream user ID unique for every user. So let's reproduce the issue. We go to the Discover Profiles menu, which is the first menu. We intercept the GraphQL request with the operation name called Discover Profiles, and we see multiple stream user ID. We will pick one. In this case, this one ending in B4F, which belongs to user Clo. So now if we read our messages, we will find this request to the endpoint/channels. And if we delete this part of the request and only leave the parameter members in, and we add the victim's stream user ID, we will see our victim's messages. And in this case, if we search by the text property, we will see the first message, hi Clo, and then searching for text, we see that the user Clo sent and received a total of 92 messages. So just to recap, we found stream user IDs, we read our message, we replace our stream user ID with that of the victim's stream user ID that we found, and we get access to their messages. So this was another access control issue. Now, vulnerability number 3, this is probably the most interesting ones. So this is about unauthenticated access to other people's attachments from their chats. So in the chats, you can send photos and videos, and photos can be replayable or view once only. And then the videos can be replayable or view once only. I've discovered that you can get all of them, get access to all of them unauthenticated. So let's see how we can reproduce this issue. So to give you the high-level overview before going in reproducing the issue, let's take the first example, photos replayable. So the photo first gets uploaded on a third party, unauthenticated, and then it will become available authenticated to the FeeId codomain under this two endpoints / photo ID. Because the backend doesn't even check the sender GUID or the receiver GUID, you can just add an X here, all it matters is for the photo ID to be valid, and the photo will be returned to you if you add this photo ID, as long as you are authenticated. And then to get it unauthenticated, we will have to find a feature of the app which will leak us this URL in order to get it unauthenticated. And there is such a feature in the app which gives you this URL to leak it and give you access unauthenticated to photos. So to upload, you go down, and then to exploit an attacker, you go from the bottom up. This would be the path. And for the time-limited photos, it's similar. First, it gets uploaded on the third part unauthenticated. And what I believe happened with the developers is we need an extra feature. We want to send sensitive photos. How can we, let's say, delete the photo from the sender? How can we implement that? So probably they reached the conclusion, we have it in one point, let's create 2 other endpoints. We get more control because it's on our domain. We will delete it from the receiver once the receiver saw it, and then it will be available only to the sender. So I believe this is what the developers assumed and wanted to implement. And in this case, we will, the difference is that we will need actually the sender's GUID, because the receiver will be deleted and unavailable after 10 seconds once the receiver sees the photo. So we will definitely need the sender GUID and then to leak the URL for unauthenticated access. So let's reproduce the issue. I need some water a bit. Let's reproduce the issue. We upload a replayable photo. There will be a GraphQL request with the operation name called Cloudinary generate upload credentials. The photo gets uploaded on the third party website, apicloudinary.com. And then there will be a GraphQL request with the operation name called upload chat attachment. That will give us the unique photo ID representing our photo. And I suspect this request is the one that will create the other 2 endpoints. Okay, and once we have the photo ID, it will be sent in the chat in the attachments array saying that replay mode is replayable and this attachment is of type image, and it will be sent in the chat. So now, if we are the attacker and we read here the messages of our victim, we will see an attachments property saying, hey, this attachment is of type image, this is the property, the photo ID, and is of type replayable. So now we just copy this photo ID and we build the URL. So if we build the URL cdn chat attachment /x, because they didn't even check the profile ID /photo ID, we will get the photo ID that we should not have access to. Okay, so this is how to get access to the photo. Now, if we make a request to the v1 endpoint, so we just add a v1 in front of it, we will, the server will return to us the URL from the third party. So using this URL, we will get access to the photo unauthenticated, as you can see in this browser. So this was just functionality of the app that was leaking the URL from the third party. So now we also have access to the photo unauthenticated. Now, to reproduce the issue for the time-limited photos that delete themselves, compared to the previous process, there are 2 main differences. One, there's an extra parameter, visibility milliseconds 15,000, saying that the photo will only be available 15 seconds. And then for accessing the photo, we cannot only just leave an X for the sender and receiver GUID, we will need their actual GUIDs, because in this case, they validate it, but we can easily find it out and get the photo. So let's reproduce the issue. We upload the photo, time limited to 15 seconds. This is the first request to to the third-party domain. Then the request that it will, with the parameter visibility milliseconds, saying this will be a time-limited photo, and I believe this is the request that will make it available to the other two endpoints. And then we read the chat, the victim's chat, as an attacker, and we see the attachment section giving us the photo ID that we want to access, and that it's view once only, this photo, this attachment. So now, to retrieve the image, we will need the profile ID of our victim that sent the photo. And the two URLs to get the photo authenticated are /cdn/chat attachment /receiver /photo ID, and then /sender /photo ID. But the receiver one will be deleted once the receiver sees it. So we will be obliged to use the sender's profile ID /photo ID endpoint in order to access it. Once we get the, for example, if we try to read the photo after it was seen by the receiver, it will tell us 404 attachment has expired. So indeed, if you're not fast enough and the receiver saw the photo, then the photo was already deleted. You need the sender's endpoint. And then once we got the sender's GUID and we saw the photo, all we need is to add the v1 in front of the endpoint, and then we will get the URL to the third party where we get the time-limited photo unauthenticated. Okay, and this is the time-limited photo which should be deleted, but it is available on internet unauthenticated, and this is from my desk office, from the view from my office. Okay, let's go to the next one, uploading a normal video. Let's try videos as well. We pick a chat, we upload the video, we record it and upload it. And this will be the first request, and it will tell us that the URL where the video was uploaded on streamiocdn.com and the endpoint. And then this URL will be pasted in the chat, and we can see in the attachment section the URL of this video. So let's become the attacker. We read the messages of our victim, and we see the attachments saying this attachment is of type video, this is the URL, this is the duration, and it is replayable. So we just copy the URL, we replace the special character \0026 with the ampersand sign, we paste it in the browser, and this is a nude office with the view from my office. I'm kidding, it's a normal video. So we got access to it, it's public. Now let's try upload play once videos. We do the same, we record the video, we upload it, it will return to us the URL. It will be pasted, the URL will be pasted in the chat with the property view once only. And we do the same. We read the victim's messages. We see the attachment section saying duration 0, replay mode, view once only. We replace the special character ampersand, the 0026 with the ampersand sign, and we will get unauthenticated access to the video. So this is how we managed to get access unauthenticated to all the attachments from the messages. This is before and after the receiver sees the videos once. Before you have tapped to view, and after you saw it, it will say video expired. So the receiver will have no knowledge that anyone else has access to this video that expired for the receiver, but in reality you can go online and watch it continuously without any knowledge for the sender or receiver. Vulnerability number 4. Let's see another access control issue. Delete, recover, and edit other people's messages. So we discovered that we can recover other people's messages that were deleted in the chat. The endpoint is /messages/message ID, and the methods are delete and put. So let's reproduce the issue. We enter a chat and we leave a message such as, got any plans for tomorrow? And we see in the response 201 created, got any plans for tomorrow? And the message ID is ending in 8AD. So we delete that message in the app and we see the endpoint /messages/message ID. And in the response, it will be reflected, got any plans for tomorrow and the message ID. So now let's try to read this message as an attacker. We paste the stream user ID for that victim. And we see that for the message ID 8AD, it will say this message was deleted. So far everything worked as expected. Now as an attacker, let's try and apply again the method delete on this same message ID. And in the response, we will get the original back. So just by deleting it one more time, we got the original message back. So this was another example of access control issue. Now let's edit a message and we will reproduce the issue. We will send the message. My phone number is 123, will be reflected in the response. My phone number is 123 with the message ID 7E2. So we read the messages of our victim. We see that my phone number is 123 with the message ID 7E2. The victim receives a notification for this message. My phone number is 123. And now as an attacker, we edit the message saying my new phone number is 456. My new phone number is 456 in the response for the same message ID 7E2. And now when the victim taps on the notification, it will see the new updated message saying my new phone number is 456 and the small edited sign below, but there is no knowledge regarding who edited the message, if it was the original sender, the attacker, or someone else. So the victim will have no knowledge regarding who edited it. Vulnerability number 5, update someone else's profile information. So you can update someone else's profile information, including name, sexuality, age, etc. The endpoint is /GraphQL, and the operation name is profile update. So let's reproduce the issue. We update our own profile. We are logged in as profile 91F, as seen in this header. And we update our bio to ABCDEF. And in the ID parameter, we changed our profile ID value from 91F to that of a testing account called 29C. And we can see in the response 200 OK, saying that for the 29C profile ID, the BO has been updated to ABCDEF. So that request worked OK, and the access control is missing in this case as well. So we managed to update someone else's profile information. Now a vulnerability that I like, number 6, get a like from any user profile. That was very interesting for me. So you could send likes from profile number 3 to profile number, from profile number 2 to 3, while logged in as profile number 1. The endpoint is /GraphQL, operation names profile like. Let's reproduce the issue. So we are logged in as 29C, and we send a normal like from us, 29C to 91F, and it will say 200 OK sent, status sent. So this worked normal. Now let's try to revert these two profiles and send a like from someone else to us, from 91F to us, to 9C, and it will say you cannot like a profile you own. So in this case, let's try a random profile ID towards another random profile ID. So in this case, we are logged in as 29C, and we send a like from 6D3 to 91F, and it will say send. So the question now becomes, who is 6D3? Who did we send a like towards our testing account? So now we apply the profile query operation on this 6D3 account to see who we just controlled, and we see that It is imaginary name Annie, gender woman, and because we have premium subscription to this mobile app, we will see it in the likes menu that Annie was last seen 1 month ago, and this is the profile of Annie. So we managed to control the likes operation. Another access control issue. Now another vulnerability, send messages in other people's chat. So we discovered that we can send messages to other people's chats, even though we are not part of that chat. We are not member of that chat. The endpoint is /channel/messaging/channel ID/message. The method is post. So we read our victim's messages, we find a channel ID, and we keep that in mind, ending in 0BD. We send a message to that channel ID, to the endpoint we just mentioned, with this channel ID 0BD, and we say hello from the attacker. The chat displayed here is between two users, D and Bogdan, but the notification comes from user B, which is not a participant in this chat. So the victim can see this. However, because in this app the names are not unique, are imaginary, as an attacker you can take any name. It's just a feature of the app. So you can impersonate anyone. Then last vulnerability, last access control issue, we can view other people matches. So we can check who did other people match with and their full profile information, such as imagine name, age, photos, etc. The endpoint is /GraphQL, operation name, chat list query. So we are logged in as 29C and we check out the matches for our own profile, 29C. And if we search in the response for imaginary name, we will see that we have 3 matches on our account. However, if we change the profile ID to that of a different account, in this case ending in 91F, and we search for imaginary name, we see that this account 91F has 45 matches. So this is another access control issue that is missing. Now, for remediation. For developers, implement authorization checks between users. This must be on the back end, not front end. Implement user levels, basic user, premium user, admin, and based on these user levels, implement access controls between them. For DevSecOps people, integrate security tools in your CI/CD pipeline. For this type of issues, access controls, it will be challenging to discover this type of issues because the tools, I'm not aware of a tool at the moment to differentiate between IDs, GUIDs, in order to discover this type of issues. For CISOs to do the data mapping and implement data protection measures, there have been fines regarding Uber for sending driver licenses from EU to US, and on TikTok for sending EU data to China regarding GDPR. And then remediation. All the issues have been remediated by FeeId. To the best of my knowledge, it took them approximately 6 months. And then after 6 months, we published this blog post, but all the issues have been fixed. For the full article, you can find the full article on our blog post. This has been also highlighted in The Guardian, and I will publish the slides on our GitHub in case anyone is interested. And now a short video summarizing all these issues.
Hello, I put one foot in front of the other, but stuff still happens. So what's up? Polyamory is all the rage these days, but what if your data was polyamorous? Dating app Field is trying to be something different. They want to give you more options to dial in exactly what you're looking for. And they also exposed all of your information to everybody, all of them, it's whoa. I want to preface this by saying that Field now claims that they have already solved all of these problems, But let's talk about what happened. Internet security firm FORTBRIDGE did a test of Field's services and alerted Field that, hey, dog, anyone can basically do anything without even needing to hack your account. These are the things that they were able to do just by poking and prodding. They were able to view photos that they weren't supposed to be able to see. They could read, edit, and delete other people's messages. They could send messages in other users' chats. They could edit other people's profiles. And they could also view other people's matches. And that's not the exhaustive list. So how did they do this? Did they hack into the mainframe? Did they, steal the CEO's thumbprint to get past biometric security? No, they just kind of looked at the data. Buckle up, boyos. We're gonna get nerdy with it. It's time for an education. When an app interfaces with a server, it uses a thing called an API. Basically, Field's API was hella fucked. The researchers looked at the data that was being sent to their app and found that their app was loading data that they weren't supposed to have access to for the purposes of showing them that they don't have access to the data. Like, here's a person's picture, they're blurred. You're supposed to have to match with them or subscribe or whatever before you can actually see the photo, but they sent the photo to your phone and then blurred it on your phone, so you actually have that data. Now, the average user isn't going to just randomly stumble upon this, but a bad actor wouldn't have to do a whole lot to get that information. But what's worse is they started then pushing back on the API, saying, hey, API, I swear I'm this other user. What can you do for me? And the API was like, oh baby, I do it all. So yeah, they were able to pretend that they were the app and say, hey server, I'm that person. Let me edit their profile. And the server was like, yeah, sure, that makes sense to me. Yeah, you absolutely are them. Consider this metaphor. You walk into a doctor's office and walk straight to the front desk and say, I'm John Wanman. I want my medical records. And they're like, okay, John Wanman, here you go. Here's your medical records. And then without breaking eye contact, you're like, I'm Lisaman. Also, give me my medical records. And they're like, absolutely, Lisaman, here you go. Here's your medical records. You're like, okay, cool. Neat. Field was alerted of these vulnerabilities back in March, and they didn't fully tackle all of them until August, apparently. The blog post came out just last week. So hey, it's really easy to hear stories like this and be like, oh, well, it's the internet, my data's everywhere, it's not worth even bothering. I really encourage you to push back.
This was a short summary from a gent I don't know, but I found it online and I found it funny. For similar research and blog posts on web apps, API testing, and phishing, you can check on our blog post. And now a short Q&A in case anyone has any questions on this access control issues. Sure.
Did you get this as a project to work on for your company, or was it just like a?
No, it was just research on my free time.
Yeah.
Yeah.
Were you working for them anyway, and then you did the research, or
No, so
right, okay.
We didn't work for them.
Okay.
I just did my own research to see how secure a dating app can be.
Right.
And I was not expecting what I have found.
No.
So then after doing my research, we contacted them, we told them, here are the issues.
Yeah.
We helped them fix, and it took a bit of time.
Yeah, sure. And they've obviously publicly contacted all the users, but do they have audit data? So if you're on that app where you have sensitive photos, those could have been exposed to anybody. Do they have that data?
I'm not sure I understand properly what you mean or what your question is, but what I will say is that once you get the photos and videos unauthenticated, I don't think there's a way to track it.
Right, they don't have logs or...
Because if you get it unauthenticated, you can, let's say, use a VPN through Hong Kong or...
Oh yeah, sure.
And
but
then
you technically would have the log that's being accessed. So there's a big difference.
Yeah.
There's a big difference between I've got 100 photos on there and there's no logs to show that any of them have been accessed, or there's thousands of unauthenticated accesses. That's what I'm trying to say.
So you've got
so
to
you know whether you've accessed them.
So if you're going to the CDN, right? The CDN, if I understood it, was completely unauthenticated anyway. So you don't need to pass a bearer token.
correct.
But you need to go through their API to get that URL to the CDN. So like, if you assume, if I've gone on there as a bad actor, my bearer token identifies I've seen this API URL, right?
Whether they log that.
Yeah, or how long they must have some logging of it, right?
But that's what I'm saying.
Or maybe not. To be fair, like you might get, you might have switched it all off, or you might just have a URL.
Because if you logged every time a picture is accessed, then you'll bring up pages that will blur it. You just have to log them.
Yeah, but you had some website logs for everything. So if someone scraped the Never like API and downloaded everything, they should know.
Well, from my perspective, if it's unauthenticated and you use a VPN to get access to that photo, on the CDN will be a log for that IP from, let's say, Hong Kong. So now the question becomes, they have to track the VPN from Hong Kong, talk to the VPN, please tell me who this IP belongs to so I can track them. And then the question is, why would a company from Hong Kong talk to you, giving you sensitive data? So it becomes a huge...
I suppose there's another area. If you left your front door open, that doesn't mean anybody's been in it. But if you had a log of how many times it opened and it was 0, you know nobody's been in it.
Okay, I see the
you
point.
don't know who came in because you haven't got video of it. That's the sort of
That's
thing.
the thing, yeah. Because
So you know if your account's been breached.
I see your point.
The logs.
And you can see that, more concretely for like things like reading messages and stuff like that. But it does rely on audit data being there in the first place, and you might not have that.
Have you been back and checked all these vulnerabilities? Asking for a friend.
Yes, all of them have been patched. Yeah.
Or have you seen any new ones?
I didn't check for new ones. Yes, they have.
Okay. Thank you. So to me, it's the API service sounds like a kind of a service, like a test that has been written to pass all vulnerability failures that you could imagine. So my own interest would be what were the biggest discoveries you've had in terms of what are the biggest discoveries, like exploits, or I know there are a lot of bounty programs from many companies like Apple and Google. So what are the top 2 discoveries that you've been able to identify? Because that's example of that product is clearly poorly written. Yeah.
So
it looks deliberately written to pass all the cases of vulnerability checks. So I'm interested in learning about the toughest discoveries that you've had.
the most interesting that the company I work for, we discovered in general and not only for this app. Did I understand correctly?
Definitely.
So you can check our blog post page because
Maybe something we can discuss if you from the title of the presentation.
so if you search for FORTBRIDGE on our blog post, we publish the most interesting ones we published on our blog post. Do you want a short? Yes, so we have 2 interesting ones. This is one. 1 second to remember exactly what happened, because it was two race conditions combined, which you don't find that very often. So my colleague started analyzing, this is a very interesting issue in case someone is interested in PHP internals and how the random functions work. So my colleague did a source code review on CMS similar to WordPress, but this CMS is called Concrete CMS. And what my colleague discovered is that in this PHP CMS, they allow upload functionality, and they will save the file on the server for 1 second, 1 split second before it gets deleted if it doesn't pass validation. So what he discovered is that every file that doesn't pass validation and gets deleted will be uploaded to a random name location, random endpoint, using the random PHP function. So my colleague analyzed the internals of the random PHP function, and he saw that not random PHP function, random PHP function.
So basically, they found the vulnerability in concrete sense.
Yes, because the file was uploaded and then afterwards deleted. So what he managed was to guess the path. In that one split second, he managed to extend the time before it gets deleted to 60 seconds. And in those 60 seconds, to brute force again the endpoint in order to access the PHP reverse shell that he just uploaded. So in 60 seconds, he managed to do 2 brute forces in order to access the reverse shell and get the callback. I don't have all the details at the moment because it's not my research. And it was quite a little bit complicated to brute force the random function and understand the C functionality of the PHP random function in order to brute force it. So my best suggestion would be to get to this link, but that's the main idea of the blog post.
What were they like to report to? Did you report directly? Did they offer you anything? Try to sue you?
Yes, we contacted them directly. Initially, we got a link from their bug bounty platform, but the bug bounty platform was not working. The link was not working for us. So in the end, we just messaged back and forth, providing more and more details and asking for more status updates. Until in the end, after 6 months, everything was fixed. We were not expecting, we were expecting a little bit faster, but in the end, it is what it is. Yeah.
Is GraphQL particularly bad? You mentioned it's all GraphQL. That's part of the vulnerability.
So it was a mix, maybe half and half, half GraphQL, half REST APIs. Which one is better or worse? I don't think there is one better or one worse. I would say we use whichever is more familiar to you and you feel more comfortable with. There has been a lot of GraphQL people going towards it because it's more recent, looks better, it's a new technology, more attractive, more flexible maybe.
I just wondered if, because it's so flexible, I wondered if that somehow made it more vulnerable, but I think probably not. Maybe they just didn't think of it.
This is the drawback. If you are not familiar with the technology and you do not know the weak points and what you should look for, if you do not look for it because you're not aware of it, then you will definitely miss it and make it vulnerable. So if you're comfortable with REST APIs, then use REST. It might be a little bit more of work for some specific apps, maybe like this one, but it will be more secure.
Did you find anything what actually returned forbidden?
Did I find what?
Anything what returned the status code forbidden? Or did it just leave you open? So if you try to use something, your own profile. Yeah. It's not really. Yeah, so was there anything that came back saying you was unauthorized to kind of do some requests? Or did you just accept any user training, any operation?
Usually it was accepted. It was forbidden usually when, let's say, the photo deleted itself and the endpoint was not accessible anymore, and it was becoming, I think, 403 forbidden.
Okay. I guess it's consistent. Consistently done. I don't understand how you can mess up so bad.
Cool. If there are no questions.